Good afternoon, good evening, everyone. My name is Zitong. I'm a solution architect from Kyligence. Our company is founded by the creators of Apache Kylin, which is a top-level open source Apache project. The mission of the company is to simplify and automate data management and analytics on multi-cloud. Right now, Kyligence is actively contributing back to the open source community and not limited to the Kylin project. As a data engineer and architect in my career, 70% of my time I'm working with the open source technologies. Why do people love open source so much? First of all, it's free, obviously. Free means it's open up for all people to engage at their own will. In big data world, with the nature of various kinds of data and business requirements, it's very important to have a customizable solution. Open source projects motivate people to innovate and publish the work they are proud of, which in return enables more choices and engage more people. Popularities also brings in standards. A good solution widely accepted will be integrated by other projects in the ecosystem as well. And finally, people can benefit in personal growth. Tons of supports and educations are available online and will likely open up new opportunities in one's career. So many good reasons for open source, but I'd like to point out that free does not mean effortless. All the good things with open source comes with a price that the user has a bigger responsibility. From understanding whether it's the right solution to master it in the actual use case. We'll start with a general data pipeline for analytics. Usually it involves these 4 phases. First, we collect data from the source, like events or transactional data. Next, running some process that people usually refers to as ETL or ELT. Things like enrichment, correction, or join with data from another system. Then to land the data into data warehouse or directly on data lake. Finally, we consume the data by running analysis. The order can be different, and there could be more than one iterations for process, store, and analyze. A pipeline may deal with various types of data, which can be divided into 3 categories. Structured data are those already well formatted. For example, sales data stored in transactional database. Unstructured data are free-form text, images, and videos. Semi-structured data is between the two, like JSON, XML files for whatever purpose. Here are some typical use cases for the data collected. Analyze customer profile, retention rate of a website. Analyze how ads revenue performs, so can understand the operational efficiency. Detect any fraud in real time or find out abnormally from logs. Enable customers to do self-service analysis. Recommend things that customer might be interested. So looking at various use cases, the requirements are also diversified. It could be in data volume, data refreshness, availability, scalability, concurrency, throughput, security, governance. However, there is really no one solution that fits all. Therefore, you may have heard thousands of open source projects. I'd like to break them down, the most commonly used ones, into the following category. Platform, ingestion and ETL, streaming, which can be considered part of the ingestion and ETL as well. NoSQL, SQL, machine learning, report, and visualization. Well, the list is actually much longer. I'm going to focus on the few that I have used and found really awesome. First, let's talk about platform. Since we are dealing with big data, a distributed processing framework is the first thing to consider. People should have heard about Hadoop, which is based on MapReduce programming model. Taking the word count as an example, the input data files are splitted, generating key value mappings, and then shuffled and merged to get the final result. In fact, MapReduce alone is an open source project, and it's the core building block of Apache Hadoop. Along with it, HDFS is another key project in Hadoop, which we'll talk about later. In practice, people realize that the original MapReduce implementation is slow for keeping intermediate data in disk. What about using in-memory storage instead and train multiple iterations together? That's how Spark is born. Spark is still using the MapReduce concept. However, it's revolutionary for its performance and ease of use. Based on resilient distributed dataset, aka RDD, an abstract layer that can represent data with multiple partitions. Spark provides APIs for SQL, streaming, machine learning, graph analysis that really caters for various analysis needs. Next, we're going to move to the ingestion and ETL category. Apache Nifi is a pretty impressive tool. For that, it provides a visualized way to design the data pipeline. And it ships with many out-of-box modules for common tasks. Users just need to fill in parameters instead of coding. It is quite intuitive for new users. Airflow is used in comprehensive ETL workload management. With Airflow, user can schedule, monitor, and visualize the workflows in graphical views, either a DAG or a tree view. It is gaining popularity on the cloud as a service. Apache Kafka is a distributed event streaming platform. It is high performance and reliable message processing. Plus, it can connect to most data sources and systems, which makes it a popular choice in modern data architecture. Coming to storage. HDFS is a fault-tolerant distributed storage. Data files are divided into big blocks and store multiple copies randomly distributed across the cluster. This architecture avoids node failure causing data loss and enables high throughput, while providing a user interface pretty similar to using a regular file system. While HDFS is good for sequential data access, it lacks random real-time read and write capability. So Apache HBase is the one which supplements HDFS on that. It is a NoSQL wide columnar store, using row key and column families to access data. Another popular NoSQL database is Mongodb. It is a document database. The advantage of it over SQL is that it can support flexible schema, avoids complicated joins, and simplifies data modeling. There are other projects in the NoSQL category. For example, masterless wide columnar store Cassandra, in-memory key value store Redis, and the graph database Neo4j. The NoSQL stores usually comes with its own analyze interface. So now let's look at some most popular tools for common analysis. Superset is a lightweight visualization tool for BI that can integrate with various data sources. It renders charts, dashboards, and it's fully customizable. Jupyter Notebook is a powerful tool that it can provide interactive programming and analyze with language like R and Python. It is very helpful for exploring and experiment with the data. For serious analysis work, you cannot avoid SQL. Hive, Spark SQL, Presto, this may be the most used for ad hoc queries. They are what we call MPP engine, which stands for massive parallel processing. Providing a SQL interface, like a traditional database and data warehouse, the workload is distributed across the cluster, makes it scalable for terabytes of data. However, to support larger scale of data or high concurrency while keeping good query performance, you will have to scale out the cluster by adding more and more resources, which is going to be costly. So is there a way to enable low latency, high concurrency SQL-based analysis while keeping the cost reasonable? My colleague Rachel is going to tell you more.
Thanks, Zitong. I'm going to switch over to my screen. So I'm going to be talking about Apache Kylin. As Zitong mentioned, our company, Kyligence, was founded by the founders of Apache Kylin. So before we get into kind of like what Apache Kylin does, I wanted to talk about Olap. I'm sure many of you are already familiar since you come from the database world, but Olap stands for Online Analytical Processing. It's a great way to do analysis. So usually typically used for like BI reporting and quickly answering questions such as what products should we put together? What are our top 5 best-selling products in each state? Things like that. It's less commonly used for, or maybe not so good at, databases that need to be updated frequently, or they have like frequent deletes, or something like a transactional database. So this is kind of an image of the Olap structure, the data structure for a cube. So you can kind of get a feel for how that works with this image. You might ask a question, how many beers were sold in Los Angeles in June? And you guys can kind of see that that's 90 based on the cube structure. So this is how the data is stored, just as a general concept in Olap and in Apache Kylin. So traditional Olap tools are like Microsoft SQL Server, IBM Cognos, MicroStrategy. Maybe you've heard of some of these. And they're great, but they do have limitations. So for example, the traditional Olap tools are maybe have difficulty handling like large data volumes. The cube size, it's not on a cluster, so the cube size might be limited by a single machine. And they might have trouble then maintaining a lot of cubes. It's hard to scale, and it does take a while to build the cubes on these tools. So our founders and the founders of Apache Kylin were running into those issues in 2013, and they started a project to solve some of them through Apache Kylin. And when creating that, they made it open source, and it became an Apache top-level project in 2015, so very rapidly. And then our company, Kyligence, was founded in 2016. So this is the architecture of Apache Kylin. And what's cool about this is you can kind of see how it's built on other open source technologies. So we have Kafka and Hive, which is the Tom talked about, Hadoop and Spark. We also have Parquet storage and HBase. And then it connects in with different BI tools like Tableau, Excel, etc. So I think Apache Kylin really shows how you can leverage different types of open source to create your own open source project, and how these communities just work together, and sometimes are composed of the same types of people that are contributing, things like that. So due to like the distributed nature, Kylin has great performance. So this is comparing it just to SQL on Hadoop. And you can just see the latency as the data increases. It's just much better. It almost is even, whereas Hadoop, and with most platforms, as you increase your data size, your query speed will be slower. But for Kylin, we don't really see that. As you increase the data size, because we're storing in this data cubes and it's distributed on a cluster, it really isn't increasing in latency. So it really is fast. This is the data flow for Apache Kylin, just kind of more of the architecture. So you might have, you can see on the top here, like a query come in over the API or JDBC, and it drops down to the REST server, the query engine, and then it's pulled from the Olap cube. And then on the bottom, you can kind of see the build flow. So the build flow would be, you might have data stored in like Hadoop, and then it's built in the cube, and the cube then would go to this side, and that's where you're querying from. So you can kind of see that flow for data. And due to like limitations in streaming, because sometimes it's not as reliable, Kylin also has a Lambda architecture. So this is to increase the reliability of your data. So on the top, you can see the streaming flow, which goes through like Kafka, Flink Spark, and then at the bottom, you can see like the batch flow to refresh the cubes. You could use both in a Lambda architecture. And I'm going to show you as a demonstration. Before we get into the actual demonstration, I kind of want to give some background. So I'm going to be running Kylin on Docker. This is like probably the best way to get started. If you guys just today wanted to check it out, you can use our Docker container. If you're not familiar with Docker, it's a great way to containerize applications so that they're stable and everything's up to date and you don't need to deal with versions or anything. And it just comes with, you know, an image of all the different things that Kylin runs on. So I've already set it up. I'm going to show you how I did it, but it's probably the best way to get started. Obviously, it's not like an exact replica of what it would be like to deploy Kylin on your system, because this is just on my laptop. But it's a good way to just explore and get familiar with it and start learning it. And then I wanted to kind of talk about the data set a little bit before we get started. So this is publicly available movie box office revenue data. It's a really small data set because it's running my local, but it's a star schema. It has the back table is revenue, box office revenue for each day. It's from the early 2000s, best time of my life. So pick that. And then it's tied in with movie genres and dates. So I'm running a Linux virtual machine on my laptop right now. You can actually run the Docker right on your Mac if you use Mac or Windows. I usually use Linux. That's typically how Kylin is deployed. It is kind of a pain to set it up, a virtual machine on your laptop. So if you guys ever have issues, like send me an email. I have lots of opinions and lots of advice. So I'm happy to help with that. But I've already started the Docker container because it does take like 2 minutes to start. And so you can see here, it's already distributed all the different ports. So I am able to access it. Actually, this is a virtual machine, but I'm able to access it through my web browser by just copying the IP address. So I have an IP address for my virtual machine, and I'm able to just use a bridge network to connect in. So I've already done that here. So this is just that IP address and then the port for Kylin. So this is Kylin's user interface. It's actually really intuitive, which is great for open source. So the first thing I did was create a project, which I called demo. And then I created a model. And the model is telling Kylin how the data is related to each other. So it's telling Kylin this, like that box office revenue is joined with dates on dates and things like that. So I'll just go back to that to show you. And by the way, the data I pulled in, I had to, I created a Hive table. I think there's also a CSV interface, which is super easy to get started. I did it through Hive and HDFS. There's a couple different ways you can load data in. So that's what I've already done. And then this is just the joins. It's kind of showing that relationship, like where it joins. So date matches date and movie, the IDs, the keys match. And these are my different tables that I'm going to be using. And my measure is the revenue. So I'm going to be looking at the sales data and adding it all up to create a revenue number. This is the partition. This is when you actually deploy a really useful thing. So it's so that you can build in like batches or segments. So for example, if you only want to build a certain segment, maybe the most recent 3 months, you could do that instead of building everything. Because this is just an example, I kind of have a pretty small data set, so I'm just going to build everything. So I'm not going to use that. And then out of that model, I can build my cube. So I've already done that. Here's kind of just the cube I built. I didn't choose every dimension that was available. I just choose the ones that I kind of wanted to explore. So like title, main genre, the subgenre, and then all the date. Because maybe I want to look at like how different genres of movies do on what day of the week, for example. So then I created that sum just through the user interface, super easy. At this point, I hadn't even done any SQL, so that's a plus for me. And then, yeah, the rest is just kind of optional. I created these aggregate groups, which is a way of limiting the amount of cubes you end up building. But it didn't really need that too much because I don't have that much right here. So I'm actually going to query this using a Jupyter notebook. If you guys have ever used Jupyter notebooks, you know that they're very fun. You can kind of get on a rabbit hole. It's a great way to explore data. And it's a great way to show your work too, because you can kind of create these nice looking programs. So this is my Jupyter notebook. And I had installed already the Kylin Python client library, and then that runs with SQL Alchemy. So I have that as well. And by the way, I'm running this out of like a pip env. It's like pip, but it's like the environment. I don't know if any of you guys have used it, but it's a great way because I don't know, like if you've used Python a lot, sometimes it gets really hard with all the different versions. And this creates like a little virtual environment for your Python code. So it makes it like a lot more portable, a lot easier to share with people. So I recommend that too when you're getting started with something like this, because it might require a lot of different types of versions. So the first thing, I have to import those libraries. And then after that, I have to create, like instantiate the connection to Kylin. So I generate this Kylin string. It's really straightforward. And then I just run this function to create it and instantiate it. And now I'm going to explore the data with pandas. If you've ever used pandas, super fun, super easy to try different things, and a great way to work with data. It makes it a lot easier than a lot of traditional tools. So I'm going to use pandas and load in a data frame. And I want to answer the question like, or I want to explore kind of what is the revenue for romantic comedies on Sundays? So ticket sales that were sold on Sundays for romantic comedies in 2001. So I wrote that SQL, and I just have to run the code, and I'm calling just the first 5 rows, and you can see it happens right away because Kylin's super fast. But you can see that, so for 2001, the top ticket sold on Sunday for romantic comedies was Down to Earth. And then the second top one was Bridget Jones. So love that, love that movie. But we can even see, it's like, maybe you'd want to be like, well, I kind of want to see what Monday was like. So if I type in Monday ticket sales, now it's actually completely different. So this is a great way of showing kind of how you could use Kylin to create really quick insights when you're connecting with Jupyter Notebook. So you can actually see here that Bridget Jones isn't the second top one for Mondays. Actually, it's the 4th one. So I'm not sure why, but that's something that you can use pandas to kind of explore. And then I also just wanted to show you some of the visualization. I'm going to do a plot bar chart. And I think that's actually part of the matplotlib, but it's kind of part of the pandas ecosystem. But there's just, it's like infinite. There's so much you can do with this, and you can find pretty much everything online, which is great. So I highly recommend this as a way of visualizing your Kylin data. And I also know Jupyter notebooks are used a lot for like machine learning and things like that. So if you do happen to, I'll send this out and you guys can take a look if you're ready to get started. And if you do happen to use it for anything interesting, like send us, share it with us, send us a tweet and we will share that. So just as a recap of what I've showed here, I showed you guys how to use Docker to create a really stable, quick instance of Apache Kylin. And then we looked at how to build a model with Apache Kylin, and then how to build a cube. And we were able to query that cube really quickly out of Jupyter notebooks. So I'm going to switch back to the slides. So we're at Kyligence are big committers into Apache Kylin. There's also people who are not involved with Kyligence. It's really a community thing. And so we invite you to join the community, commit to Apache Kylin. You can join the mailing list. It's also a great way to keep up to date with like other people's experience, learn more about questions people have and answer their questions. And then we also have a Slack channel. Here's contact information for both Apache Kylin and Kyligence. You can just visit our websites or contact us through email or Twitter, and you can always send me or Samantha or Zatong an email if you have any questions about any of them.